Hello, in this video I'm going to solve question 4, Problems Set 1, Lecture 2, Lectures in Elementary Number Theory. Let a, b, and c be non-zero integers such that a to the a divides b to the c and b to the b divides c to the a. Show that a to the b divides c to the c. Pause the video at this point and give it a try. Okay, I want to use the theorems in the previous 2 lectures on this playlist to solve the problem, so I do not want to start from scratch, meaning the definition of divisibility. Of course, you can do that, but my goal is to train yourself to remember those theorems that we went through during the last 2 lectures. Okay, so when I see this one, I see that the base on the left is A and the base on the right is C. But here, the assumptions that I have, in one of them, the base on the left is A, the base on the right is B. In the other one, the base on the left is B, the base on the right is C. If I want to be able to connect base A to base C, so it's more natural to think about transitivity. Okay, so what is transitivity? If you have seen the previous lecture, it tells you that if a number A divides a number B and number B divides number C, then you can conclude from these two that number A also divides number C. This is what is called transitivity of divisibility relation. Okay, so this for having transitivity, I have to have these two numbers identical. So here I have b to power c, but here I have b to power b. Okay, the common thing is that the bases are the same. So let us make the exponents the same. Okay, to make the exponents the same, then it might be easy to see what to do, because if I have a to the power of a divides b to power c, I raise both sides to power b, so it becomes a to power b divides b to power c to power b, but this means that a to power ab divides b to power bc. Okay, but for the second one, b to power b divides c to power a, what I want to do, I want to make the left-hand side as the right-hand side of this. So this motivates me to raise both sides to power c. Yes, so the right-hand side becomes c to power a to power c. But if I open it, so it becomes b to power bc divides c to power ac. Okay, now I have my goal achieved. I have transitivity, yes? This number divides b to power bc, but b to power bc itself also divides c to power ac. So using this relation and that relation and transitivity that I have written here, I can conclude that a to power ab divides c to power ac. Okay, and then what I can do, I can write it as a to the power of b to the power of a for the first side, and for the second side I can write it as c to power a. Okay, but then I told you that there is also a formula that, of course, in my lectures I haven't presented a proof yet, but I told me, trust me on that, we will discuss the proof of that theorem later. And the problem was that if I have a to power n and b to power n divides b to power n, and if n is a natural number and a and b are integers, then you can conclude that a also divides b. So I told you in that lecture, take this for granted for the time being. We will use it, and then later we will present a proof for that. Okay, the problem here is that n should be a natural number in order this works. Okay, but in the problem, it was better to mention that a, b, and c are natural numbers, but I have mentioned that a, b, and c are non-integers. But then I have mentioned that this makes sense and that also makes sense. So automatically I understand that on the one hand, according to the problem, a is a non-zero integer. On the other hand, this is true. When this is true, it means that this statement makes sense. But this relation only makes sense if the left-hand side and the right-hand side are integers. If a is negative, then a to the power of a will not be an integer in general. The same is true for b to the power of c. So this means that both a and b should be positive integers, so it means a and c should be natural. For the same reason, b should also be natural. So this means that this a that you see here is a natural number, so this means that as I could do here and drop n's concluding this, here I can drop these a's. If, of course, the leftovers are integers, which in this case are. So this means that from here I can conclude that a to the power of b divides c to power c. Okay, and that is the goal that we are supposed to reach at. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.